Oh, okay. Wait. Okay. Oh, okay. Now teaching. So let's go through some basics. So what? No, not right now, please. Thank you. There we go. So we need, I'm assuming you're watching this with the goal of getting into Unity. So we're going to be doing some C sharp. I'm going to assume that you have the Visual Studio installer. So that would be this one, which you can get from somewhere. Where do you even get that from? visualstudio.microsoft.com/downloads. Oh my God, my eyes. Okay. I'm pretty sure if you just click here, it'll give you the installer. And then it asks you which, oh my God, why is everything needing to update? Then it asks you to install some workloads. That's just a fancy way of asking which dependencies and packages it should install for you. So, of course, we want to run with the game development with Unity. And I'm pretty sure if you just do like .NET desktop development stuff, you should get most of the packages you need. If you go in the individual components, additionally, you can get, let me just look real quick, because it does have the get thing, which I will be showing later. MS build, blah, 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 blah. Oh, wait, search. I'm blind. Git. There we go, Git for Windows. So you can get Git for Windows via this installer. I have it installed separately. Doesn't really matter. And then if you want to use Visual Studio to handle your Git, you can get the extension. You can also just use the console. Um, right. You install that, get it set up. We click launch. And then we're just going to start with some very, very basic projects to get used to C sharp and programming. And then we'll move into Unity. Otherwise, that's going to be quite a whiplash. First things first, on your computer, I have an entire drive for it, just my data. I have a source folder. I highly suggest you put down a source folder and then make a promise to yourself to always put all of your projects in that folder. I have sort of a subfolder here for all of my temp projects. So I'm just going to make a new project inside of my learning examples. So let's start by just creating a new project. And then it asks you a bunch of stuff. For language, we'll pick C sharp. We just want to make a console app, .NET Core, that's fine. So we have some output. We click next. We need to give it a name. I'm just going to call this teaching C sharp. Now it, for some reason, always defaults me to here. I could swear I change this all the time and it just hates me. I think you go in tools and change it there somewhere. I can never seem to do it right. And then I have my learning examples, and then I just want it in here. And then you have the option to place solution and project in the same directory. Normally, I don't do this in case that I want several projects under the same solution. So the way that um, .NET does the C# projects is it has, let me just whip out the paint, and you get my touchpad painting experience. Can I get like a real thick boy here? So at the top, you have your SLN. That's your solution file, which you'll see in a second. And that basically just holds a list of all the projects. Ooh, what's my Twitch? Wait, I'm getting asked things. 1 second. Wait, is my YouTube even in my... I don't think it is. How do I share this? Oh, there we go. Boop. There we go. And then you have a CS Proi, I don't even know how to pronounce this. Proi file. It's kind of fun playing with the touchpad for each project under there. So we could have a library, which was a project. Then we could have a different library that we were developing on the side. We could have the console application that then consumed the library we were making. So that's what it means when it's asking for that. It's just, should I place these in the same directory? And a directory, if you don't know that, that's just a fancy name for a folder. So like source is a directory, learning examples is a directory. And we don't want it to do that. Usually we don't want it to do that. Right, so let's just hit create. Where's the chat even? Can I pop out the chat? Is that a thing you can do on these? Where's the chat? Wait, where's the chat? Can people not chat? Oh gosh. Uh, that's a bit poopy. How are people going to chat? Can I go to my own video? Can people chat here? Chat is deactivated. Wait, what? No, it's not. Did I deactivate chat? If I did, I'm sorry. Wait, why? Oh, okay. So if you have to say that your stuff is not for children to have chat. I didn't know that. Okay, my bad, guys. Yeah, I didn't notice. I didn't notice. I thought I had everything set up. Can I change that while I'm streaming? Can I just go like we're adult now? Oh, here we go. Nope. No, no children allowed. Children are legal. All right. Do I get chat back? Can people chat now? There we go. Ah, okay, Google. I didn't mean to do that. Right? And then can I pop this out? Pop out. Great. There we go. Hey, there we go. So that's how that works. We got it made. So you can see here, it sets us up in the Solution Explorer, and currently it is showing us the uh, project view. Is that what this is called? It has folder view and project view or solution view. I forget what the other view is called. But yeah, this is not how your files are actually laid out in your file system. This is how your project is laid out logically. So if you click the switch views, you can then see how it's actually laid out. And if we look in my folder, I should then have somewhere in here the C sharp. Wasn't that what I called it? Uh-oh. Reload. Wait, what did I call it? Teaching? Oh yeah, teaching C sharp. Bam. We got our SLN, and then we have a folder or a directory, and then we have this CS project file in there. And Unity does the same thing. You have your solution, and then you have your project files. It also uses something called a manifest. I think it's called a manifest. We'll get to it. That basically allows you to make a library. So that's just a project where you have a bunch of functions that you want to reuse, and then you can just import that very easily into your project. Anyway, we made a console app, so we get this starting file. Now let's look a little at what that actually does. So if we go to the Solution Explorer and we go to the solution view or project view or whatever this was called, we see the solution at the top, teaching C sharp, and then the projects underneath. Let me just actually make a quick extra project here. We'll just make another. Actually, no, let's make a class library. And then let's call this teaching C sharp.lib. There we go. So here you can see we have teaching C sharp, that's the one project, and then teaching C sharp.lib, that's the other project. And we can collapse those. We can expand. So this is a class. It's not necessarily its own file. You can have multiple classes in the same file. We'll get to classes. Let's not do that straight away. Let's start out with some basics about how the project works and what the variables are and all of that. So you can collapse those, you can expand those, and you can then see what the members are of that class. And we can go to those members, such as program. Program is our entry point into our console app. Every application needs some kind of entry point to tell the computer where to start it. For a C# console app, it is program with void main. I even think if we go to the C# documentation, it should tell us the possible ways we can write void main, because there's a few different ways you can do it. So let's just try C# console app entry point. Change main command line arguments. Maybe here. Here we go. So it says here, the main method is the entry point of a C# applications. And of course, a library does not need an entry point because a library does not get run. You just reuse the stuff you write in the library in the application that is then run. Um, some of the possible ways we can write it is void main string args, and the string args part is what it gets sent when, oh, it says right here. Right, so that's all of the different ways that you can write it, depending on which kind of application it is, which is good to know. So the string args part is basically what the starting parameters of the app is. So let's just open up, let's just build this actually, and then let's open up. So I do Control Shift B to build. And we should now notice that if we go to the, let me just go to the folder. It has a bin, stands for binaries. So that is the output of our build. And then you have debug and release, which is just different build modes. If we go to our debug, then you get which framework it was built with. And then here we have our exe, which is the thing that we can actually run. So I'm just going to run PowerShell here. So I held down Shift and then right-clicked, and that lets me open PowerShell here. And then if we run, so to run it, we just need to preface it with a dot, I'm pretty sure. And then I can press Tab to go through what's in this directory and Enter to then run it. And it writes out hello world. You know, that makes sense. The console represents the standard input output. This is the console. And then we write a line that says hello world. And write line is different from write. It's just that we do a new line afterwards. You can very quickly see this for yourself if we do console write. And then we build again, Control Shift B, and then we rerun it. So I'm just pressing the up key here to go back to the last command I ran in the console. And you can see that it says hello, hello world, no space between. If we change it to right line, Control Shift B to build, back to my console, up arrow, enter, we get hello, new line, hello world. So that's just not a lot of magic there. So far, so good. Now, the string args part, let's actually try and use those. So let's just print out what the first argument of our string args is. So let's get args. And then 0. So this is an array. Right now, just think of it as a fancy way of saying list. And all lists, well, not all lists. In C# at least, lists are 0 based. So the first element in a list is at 0, second element is at 1, so on. Some languages like Lua start arrays at 1 because they are madmen. So now, if we build Control Shift B, we go back, I press up arrow, enter, we get an unhandled exception. And let's learn to read exceptions, which is what you'll be doing for most of your life as a programmer. So system.index out of range exception. Index was outside the bounds of the array. So we just talked about how this was an array. And then the little number in here, that's called the index. So that is the element in the array that we want. And then it's saying that the element that we wanted was outside the bounds of our list. So we tried to access the first element of our list, but it was not there. The list that we had did not have a first element, which makes sense because we didn't give our app any argument to run with. So let's actually try and give it an argument to run with. And then after that, let's try and make it so that even if we don't give it an element, it won't crash. So there, I just did a space, and then I just wrote something like hello. We could write foo, and you'll see that it prints out as a string. So string represents text. It says right here, if you hover over it, which is what this basically also is. If I hover over it, you can see this is a string as well, right? That's how you do a string. We'll get into types in a second. I just want you to be comfortable with how the program actually functions before we get there. And then it got the first string, which was, foo. Let's try and give it several things. So like foo bar. So now we have two things. Then it says foo, because that's the first thing in the list. Let's try and also print out the second one. So I'm going to do Control C, Control V, and then let's say 1. So that is the second element. So let's try and run this again. Up arrow, foo bar. Oh, I forgot to build. Excellent. That's what you get for live coding. There. Foo bar hello world. Let's try and only give it one thing. And I think you can already see what this error is going to be. Unhandled exception. And if we read our exception a little more closely, we can also see which file gave us the exception. So that was program.cs. That's this one. Which, which function gave us the error? That was main. This guy. And which line it was at? Line 10. Which makes sense. It was this line. Now, let's imagine that we struggled a bit to figure out that it was line 10, right? So what do? Well, we could put what's called a breakpoint. So I have my cursor out here at the numbers. You can see that my cursor changes. It goes to like this arrow thing, and then I can click out here, right? So you see how it changes? Please, sir. Am I doing this wrong? Why is it not putting a breakpoint? Wait. Did I just not click hard enough? I didn't click hard enough. All right. Right. So you go out to the gray line, you click, you get your red dot, that's your breakpoint. And then what we can do is that we can go into something called debug mode. So instead of running it from the console, we instead run it in debug from the IDE Visual Studio. So I click here. And you'll see all of this stuff happens. Whoop, there we go. And then the program execution stops at our breakpoint, and we can inspect things. So down here, we can see what our current variables are. We have args. And we can inspect our locals, I hope. And then give me arcs. Do I get to hover over it, maybe? Am I not allowed to interrogate it? That's a little poopy. Do I need to step in a little more? Step. Here we go. I could have sworn I would have been able to. Alrighty, that's fine, that's fine. Let's just do something else then real quick. Don't do this. One sec. It's been a while. Am I then able to interrogate this guy? Do I copy value? Wait, what do I even do to get the values out of it? Oh my lord. Could you stop doing that? I want the stuff inside of you. That is not your value, you silly goose. Is it just is it just specifically for that because it's not part of the editor? In which case, that was like the worst example for debugging I could have picked. Um, uh, yeah, I know I'm doing it wrong. Uh, There we go. Let me just see if that at least will work. In which case it might just be arcs. That's a poopy butt head. Oh my god, it's just arcs. That's a poopy butt head. So normally when you get to inspect things, you can click the little drop down of your locals, and you can actually see what's inside of your list. I didn't get to here because it's arcs. Arcs is special, I guess. It just tells you that it's an array of strings. That's cool. I'm not mad at all. Um, Worst example I could have picked for debugging, but yeah, so basically our little red dot here lets us step through the code. Right. That's the absolute basics of how the video that instruct. Wait, what? Anyway, that's how program execution works, debugging works, like very, very simply. I think the best thing I can do is just go through it as it comes up, and then we'll try and work towards some kind of application. So let's do some fail safes in case our user does not enter two things. So one thing we can do is we can just slap what's called a try statement around it. So you see how it said that it was an uncaught? One second. You see how it said that it was an unhandled exception? This is how to handle the exception. So we could try this, and if that throws an exception, we could then print out first parameter missing. Well, technically argument. We could try the second one, try, and then what I do to bring out the entire what's called a snippet is I press tab twice. So tab, and then we could try this second one. Second argument missing, just like that. I'm going to try building. Where's Link? Let's do one where both is there. Foobar, we got that. Let's get rid of one. We got second argument missing because we caught the exception. Let's do one without any of them. First argument missing, second argument missing. So now we still got the errors, the exceptions, but then we caught them and handled them in our user code. Another way we could do this, I believe, I don't remember if string has try get. We'll see. So do we get a try? I don't think we can try. No, we can't. Wait, do I actually have some autosave extension set? I do. 1 second. Let me just restart Visual Studio real quick. Well, if we had, oh, wait, no, I can. Okay, so a different thing we could do is that we could actually check the size. So we could say, you know, is that too complicated right now? Let's do data types first and then let's do statements. How about that? So let's do some data types. Again, let's go have a look at the documentation. Documentation. Now we have our specification. Is it in the language reference types? Let's start with the value types. So in C Sharp, you have fundamentally two different types of variables. So variable, you've probably heard that before. Just think of it as a box you can have data in right now. That's fine. The way we do a variable is that we write its type, then some kind of identifier for it or a symbol, and then we say, I forget what that is called, semicolon at the end. And we have now declared a variable. To put something in our variable, we can then take our identifier and say equals to our value, semicolon, ending line. So let's try and look at some of the types that we can use. Let's do the integral numerics. So integral just means whole number. Let's just think of it as that, whole number. So 1, 2, 4, 7, but not 7.5. We have different sizes of types. So when we think of a type, I'm going to whip out the paint again. Hide your children. Don't save. You can think of it as some space in memory. So you have a RAM. This is your RAM. If it looks like this, you should get your money back. And let's say that your RAM is in blocks of, let's say it's in blocks of a byte. So that's what? 1, 2, 3, 4, 5, 6, 7, 8. So this is a block of memory in your RAM, and it's a byte. Each of these boxes is a bit, so a 0 or a 1. Let's say that we want the number 0. Then all of these would just be 0. Let's say that we want the number 1. Then this would be 1, and the rest of them would be 0. Let's say that we want the number 2. Then this would be 1, that would be 0, and all of the other ones would be 0. Right? So we can keep going like that. Now, what I'm doing here would only cover positive numbers, because what happens if we want a, -1? Then what do we do? Well, then we need some way to tell our piece of memory that the number that is stored there is negative. So what it usually does is that it has some leading bit, which is then, flipped for negative or positive, whatever. And what you'll already notice here is that if we then want to store whether or not it's a positive or negative number, we can store less numbers. And that's where something like size becomes relevant. Because if we only need to store positive numbers, right, so we're never going to get a negative number, you can see that our upper range is larger than if it was shared between negative and positive numbers. And that makes sense because we just saw how we had to use one of the boxes to say whether or not there was a minus in front of it. This is what's called signed because it has a sign in front of it, or unsigned. So one you might have seen a lot is int, which just stands for integer. That will have 32 bits, so 32 of those boxes in our drawing. That can be either 0 or 1. And the way the computer then reads those boxes is as a number. Basically how types work, basically how memory works. It shows here an example of how we can make one. Like I said before, you have your type, your identifier, and then what they do here is they initialize it. So that's when you initially put a value in your variable immediately as they declare the variable. We could have done that as well. So let's try doing that. See if it works for us. So let's make an int. Let's call it myInt because I'm not very original. And then let's take my int and then let's put something in it, like the number 4. That's a nice number. Let's try and print out what is inside of my int. So let's do console write line, and we can just do my int inside of it. If we look at write line, we'll notice that it says here something about overloads. That's because it's able to take different things inside of these parentheses. One of those things is an integer, and then it's able to turn that into a string for us, which is very nice. So we don't have to do a lot of work to print out our integer. Let's build this. Let's go back here and let's run it. And we get 4, which was what we put inside of my int. So that's great. Now let's do something like a byte. So let's do a byte that can have 0 to 255. Let's call this my byte, and then let's try and initialize it like they said. So I'll initialize my byte to 0. And then what I'm going to do is that I'm going to say my byte is equal to the value in my byte minus 1. And you'll see here that it's not even going to let us build this. It has it underlined in red because it cannot implicitly convert type int to byte. I don't even think if we say byte here that it's going to work. Because what we're basically going to get is that it's going to go into a negative. It's going to say, you know, what you're trying to do here is outside the range of. I can see at compile time, right? So that's before we run the program. That's compile time. When we run the program, that's called runtime. So this is a compile time error where the compiler can already see that this is outside the range of what we have specified. If we do an S byte, though, what are you mad about? Please don't tell me that it's something stupid. Oh gosh. Wait. Was that the error before? Oh my god, it was. Right. So what went wrong before? Oh, that's stupid. So what went wrong before for us was that it was doing what's called an implicit cast. I didn't want to get into that already. Do we have... Where is casting? Bup, 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 bup. Do they not have implicit? Wait. Built-in types, unmanaged, nullable, blah, 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 value types, types. Is it under types then? What are they? No, that's not a thing. Overview? Keywords, operators, blah, 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 blah. Is there like a types overview? Blah, 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 blah. I need the link to where it talks about implicit casting. Okay, never mind. So what it was trying to do was turn our byte number into an integer because that would fit what we were trying to do. And when I say implicit, it's because I didn't have to do this, where it's me telling it how to convert the number. It's where it tried to do it on its own. So an example of that could be we take a let's take a byte. Um, you know, let's call it foo, and let's put 1 in it. And then we take int, let's call it bar, and then we put the value of foo in it. So even though these are different types, I haven't really got into type safety yet, but normally you're not allowed to put one type into a different type unless they can convert between each other. So here we have what's called an implicit conversion, because byte is smaller than an int. If we go to our table, we can see here that byte is 0 to 255, and int is well within that range. So we can do what's called an implicit conversion or cast, where we can turn a smaller type into a bigger type. No issue. If we then try to go back again, so we take foo and then we try to put bar into it, then we get issues because int is bigger than byte, and it's going to tell us, hey, you can't do that. It's basically asking the programmer, do you know what you're doing? Is there going to be room for this type in the smaller type? And we could tell it, yes, there is going to be room. We know what we're doing. You can turn this bigger type into the smaller type. And I would highly suggest that you try playing around with this and see what happens. Now, back to this. So let's try and print out my byte and see what happens. And let me remember to build. Now you'll notice here that we had 0, and then we set -1, and what that gives us is 255. So let's go and look at byte and see what's happening. So we were 0, and then we set -1, and that took us to 255. So you can probably see what happened here. It wrapped us around to the other end. Now this can also happen where we overflow and then wrap around to the other end. You've probably heard about overflowing and underflowing because of Stack Overflow, I'm guessing. But that's what that means. So let's try that. So we take my byte, we put 255 in it, and then we say +1. And then we tell it, yes, this is safe. Well, actually, I can't tell it that's safe because it knows it's not. There we go. And then take my byte equals my byte +1. And then we say byte. And the reason why I have to put a parentheses around the entire statement is because we want the result of what this is to be a byte. So that's why I put parentheses around the entire thing. I'll get into what a statement is, but you know, programming, it's a lot of ones, I know. When you get through the initial curve of like the steep, learning curve, it gets easier, and then you figure out, hey, I don't actually know anything anyway. and you kind of wobble up and down like that. It's a nice ride. So let's try this. My byte. Boom. Now you'll notice when I write, I don't write out all of it. So here I just start writing console, and then I press tab. I could also press control space to get back this menu in case I lost it. That's control space. And then if I do a dot, it will automatically put out console and then do my dot. Then I get right line here. I could press tab to get right line, but I can also just start doing my parentheses and it will figure out that's what I want it to do. If I lose my IntelliSense, that's what this bar is called, for what I can put inside of the parentheses here, I can do Control Shift Space, and that gives me back, what I can put in here. I can navigate the options with arrow keys up and down, and I can do Control Space to get my list of variables back. So let's do my byte. And let's build. And let's see if we are correct in that it will wrap around to the other side. So we get 255. And then we put 255 in there just to be sure that's what's in there. And then we say +1, and it goes to 0. So we wrapped around. All right. Now, I don't remember what the word for, it's like safe or something, unchecked. Is it unchecked? No. What is it? It's something. I swear I know what it is. Let me just look at these specifications real quick. Oh God, that's just the features. That's not what I want. Give me keywords. Let me just find it real quick. Oh, is it checked? I think it's checked. There we go. So what we can do if we don't want this to happen is that we can put it in a checked block. So here, if I write checked, you can see we have a code snippet for it. So I'm going to press tab and then tab again. And then I'm going to take this, Control X to cut it, Control V to paste it. And then if you want to make it prettified, like let's say it looked like this for some reason, we can do Control KD, and that'll pretty up our code a bit. I'm going to Control S to save, Control Shift B to build. And if we try this, we get an exception, overflow exception. So now we have the ability to catch this checked block. So let's do the try from before. I press tab, hold down Shift, Control X, put it in the try, and then we do console.writeLine. Oh no, overflow. Control S, Control Shift B. And let's try again. And we caught the error. So let's review what you've learned. You've learned a bit about the project structure of a C# project. You've learned a bit about what it looks like in the file system. You've learned a bit about debugging, how to read errors. We've started looking at types. We'll continue looking at types for the next stream, I'm pretty sure, until we go through all of them. You've looked at the entry point for a C# console app, and you've looked a bit about what the string args for a console app is. and how that works. Um, but yeah, it's basically like 22:40 here in Denmark land, in Danish land. So I'm gonna go to bed, and I hope you all have a productive, whatever, time of day it is for you. All right. How do I even end a stream? Let's stop streaming.